Hello everyone, this is Dr. P. Srilatha, Associate Professor of Mathematics, Institute of Aeronautical Engineering, Hyderabad. In this session, I am going to discuss about Bayes theorem. So, what is Bayes theorem? The Bayes theorem statement is, if E1, E2, E3 and so on En are mutually exclusive events, A is any arbitrary constant. If E1, E2, E3 and so on En are mutually exclusive events and A is any arbitrary event, then probability of EI divides A equal to probability of A divides A into P of EI divided by summation I equal to 1 to n probability of A divides A into P of EI. So let us consider. So this is our sample space. Here A is our arbitrary constant. So let us consider this is E1, E2, E3 and so on. This is En. Okay. So E1, E2, E3 and so on En are here events. But here E1, E2, E3, E4 and so on En are mutually exclusive events. And A is any arbitrary constant. So then we have to prove that probability of E divides A equal to probability of A divides AI into P of EI divided by summation I equal to 1 to n probability of A divides EI into P of EI. Okay, so for proof we have S equal to, we know that the sample space S equal to E1 union E2 union and so on union En. So S equal to E1 union E2 union E3 union and so on union En. And A intersection S equal to A. So we know that A intersection S equal to always A intersection S equal to A. A intersection S equal to A. Okay. So from this A equal to A intersection S. A equal to A intersection S. So A equal to A intersection S. What is S? S equal to E1 union, E2 union, E3 union and so on union En. Okay. So this is our S. Okay. So, but we know that A intersection E1 union, E2 union, E3 union and so on union En equal to A intersection E1 union, A intersection E2 union, A intersection E3 union, A intersection En. A intersection E1 union, A intersection E2 union, A intersection E3 union, A intersection En. So from that, taking the probabilities on both sides, then P of A equal to P of A intersection E1 union, P of A intersection E2 union, P of A intersection E3 union and so on union P intersection En. Okay, so P of A equal to P of A intersection E1 union, P of taking the probabilities on both sides, we will get this one. So from this, P of A equal to P of A intersection E1 union, P of A intersection E2 union, from this P of A intersection E3 and union and so on union P of A intersection En. Okay. So after applying the probability on both sides, we will get P of A equal to P of A intersection E1 union, P of A intersection E2 union, A intersection E3 union and so on union A intersection En. So that means P of A equal to P of A intersection E1 union P of A intersection E2, union P of A intersection E3, union and so on, union P of A intersection En. But here we know that E1, E2, E3 and so on, En are mutually exclusive events. E1, E2, E3 and so on, En are mutually exclusive events. These are mutually exclusive events. Then A intersection E1, A intersection E2, A intersection E3 and so on, A intersection En is also mutually exclusive events. A intersection E1, A intersection E2, A intersection E3, A intersection and so on, A intersection En are also mutually exclusive events. But we know that if E1, E2 are mutually exclusive events, then probability of E1 union E2 equal to probability of E1 plus probability of E2. So we have one condition, that is, if E1, E2 are mutually exclusive events, then P of E1 union E2 equal to P of E1 plus P of E2. Okay, so from that P of A equal to, so P of A intersection E1 union P of A intersection E2, A intersection E3 and so on, union P of A intersection En. So here A intersection E1, A intersection E2 and so on, A intersection En are mutually exclusive events. So that's why probability of A equal to P of A intersection E1, in place of union we have to write plus. Okay. So probability of A intersection E1 plus P of A intersection E2 plus P of A intersection E3 plus and so on, P of A intersection En. So here P of A equal to P of A intersection E1 plus P of A intersection E2, P of A intersection E3 plus and so on, P of A intersection En. So by the conditional probability, so what is our conditional probability? We have conditional probability formula is there. Probability of A divides B equal to probability of A intersection B divided by P of B. Okay. So what is our conditional probability formula? P of A intersection B equal to P of A divides B equal to P of A intersection B divided by P of B. So this is our conditional probability formula. So by using this conditional probability formula, so what is our conditional probability formula? P of A divides B equal to P of A intersection B divided by P of B. So this is our conditional probability formula. So by using conditional probability formula, so actually we need to find probability of EI divides A. So probability of EI divides A. So from the conditional probability formula, probability of EI divides A equal to, so from conditional probability formula, P of EI intersection A divided by P of A. So this is our condition. By using conditional probability formula, P of EI divides A equal to P of EI intersection A divided by P of A. So that is equal to, so we can also written as, we know that P of A intersection B is always equal to P of B intersection A. So like from that, so P of EI divides EI intersection A equal to P of A intersection EI. Okay. So that's why we can write P of EI intersection A can be written as P of A intersection EI divided by, so what is P of A? We know that P of A is, what is P of A? So P of A is P of A equal to P of A intersection E1 plus P of A intersection E2 plus P of A intersection E3 plus and so on, P of A intersection En. So substitute P of A value here. Okay. So P of A intersection E1 plus P of A intersection E2 plus P of A intersection E3 plus P of A intersection and so on, P of A intersection En. So and also we can, by the conditional probability, so P of A intersection B, by the conditional probability, P of A intersection B can be written as P of A divides B into P of B. P of conditional, by the conditional probability, P of A divides B can be written as P of A intersection B divided by P of B. So from this we can write P of A intersection B equal to P of A divides B into P of B. So like that, P of A intersection B or P of A intersection EI can be written as P of A intersection EI into P of EI. P of A intersection EI can be written as P of A intersection EI into P of EI. And also P of A intersection B. This is also like P of A intersection B. So this is also like P of A intersection B. So this is also like P of A intersection B. So this is also like P of A intersection B. So P of A intersection B can be written as P of A divides B into P of B. So like the P of A intersection E1 can be written as P of A divides E1 into P of E1 plus P of A intersection E2 can be written as P of A divides E2 into P of E2. P of A intersection E3 can be written as P of A divides E3 into P of E3 and so on. P of A intersection En can be written as P of A intersection En into P of En. Okay. So therefore P of EI intersection P of EI divides A equal to P of A intersection EI into P of EI. P of A intersection EI into P of EI divided by, so this can be written as P of A divides E1 into P of E1 plus P of A divides E2 into P of E2 plus P of A divides E3 into P of E3 plus and so on. P of A divides En into P of En can be written as summation I equal to 1 to n. This can be written as summation I equal to 1 to n P of A divides EI into P of EI. A divides EI into P of EI. So this is our Bayes theorem. So what is our Bayes theorem? The statement is, if E1, E2, E3, E and so on En are mutually exclusive events and capital A is any arbitrary event, then probability of P of EI divides A equal to P of A divides A into P of EI divided by summation I equal to 1 to n P of A divides A into P of EI. So this is very important theorem, Bayes theorem. So you have to remember this formula. Based on this formula we have some problems. Okay. So first one. The first problem is, box 1 contains 2 white, 3 black balls. Box 2 contains 4 white, 1 black ball. Box 3 contains 3 white, 4 black balls. Okay, so here we have 3 boxes. So given that one of the boxes is selected at random, one ball is drawn at random, is found to be white. So here we have to choose only one ball, but that should be white. Okay, so find the probability that white ball is drawn from box 2. White ball is drawn from box 2. Okay, so let us consider E1, E2, E3 are events of box 1, box 2, box 3. Okay, so let us consider E1 is box 1 and E2 is box 2 and E3 is box 3. Okay, so here E1 is, probability of E1 is, how many favorable outcomes are there? Favorable events are there, only one event out of 3 events. So that's why that is probability of E1 equal to 1 by 3. So like that, probability of E2. So for E2 also one possibility is there out of 3. So probability of E2 is equal to 1 by 3. So like that, for E3 only one possibility is there out of 3. So probability of E3 equal to 1 by 3. So probability of E1 is 1 by 3. So next box 2, that is probability of E2 equal to 1 by 3 and probability of E3 is also 1 by 3. Next, let E be the event of selecting white ball. Let E be the event of selecting white ball. So let E be the event of Selecting that should be white ball. Now we need to calculate probability of E1, probability of E2, probability of A divides E1, probability of A divides E2, probability of A divides E3. So for that, first we should write, so what is box 1 and what is box 2 and what is box 3. So in box 1 we have 2 white, 3 black balls. 2 white, 3 black balls. So in box 2, 4 white, 1 black. 4 white, 1 black. In box 3, 3 white, 4 black. 3 white, 4 black balls. Okay, so what is A? So here A be the event of selecting only white ball. A be the event of selecting only white ball. So that's why we should focus on only white ball. So here we need to find probability of A divides E1. Probability of A divides E1. So we have to, that means we have to select white ball from box 1. We have to select white ball from box 1. So that is equal to probability of A divides E1 equal to. So what is our favorable event? What is the probability definition? Actually probability definition P of E equal to M by N. So M is favorable event divided by N is total number of event. So here favorable event is. So here we have to select white ball from box 1. So how many white balls are there? 2 balls. In that we have to choose one randomly. So divided by how many balls are there? So we have total 5 balls in box 1. So that's why that is 5C1. So probability of A divides E1 equal to 2C1. Favorable events are 2 white balls are there. In that we have to choose 1 ball and total balls are 2 plus 3, 5 balls. In that we have to choose 1 ball. So that means so favorable event divided by total number of events. 2C1 divided by 5C1, that is 2 by 5. So like that we have to find probability of A divides E2. So that is equal to, so what is probability of A divides E2? So probability of A divides E2. Here we need to find, we need to choose white ball from box 2. So how many white balls are there here? Here we have only 4 white balls are there. So from 4 white balls we have to choose one randomly. So here we have to choose one ball drawn at random. So that's why we are choosing one ball randomly. White balls from box 2. That means here we have 4 white balls. So from that we have to choose one ball randomly. How many balls are there? We have total 5 balls. So from 5 balls we have to choose 1 ball. So that's why probability of A divides E2. So that means the probability of selecting white ball from E2. So that is equal to 4C1. Total white balls are 4C1 divided by total balls are 5. 4C1 divided by 5C1. So answer is 4 by 5. P of A divides E2 equal to 4 by 5. So like that we need to find probability of A divides E2. So that means we have to choose white ball from box 3. Okay. So here how many white balls are there? 3. But we have to choose one randomly, right? So how many balls are total? How many balls are there? We have 3 plus 4, 7 balls. So from that we have to choose 1. Probability of A divides E3, that is equal to, that means probability of selecting white ball from box 3. So that is equal to 3C1 divided by 7C1. 3C1 divided by 7C1. Probability of A divides E3 equal to 3C1 divided by 7C1. So if you calculate this one, you will get 3 by 7. So now the main question is find the probability that white ball is drawn from box 2. Find the probability that the probability of selecting white ball from only box 2. Only box 2. So that means we need to find P of E2 divides A. P of E2 divides A. So that is equal to, we have formula. So what is our Bayes theorem formula? A divides A equal to P of A divides EI into P of EI divided by summation I equal to 1 to n P of A divides EI into P of EI. Okay. So that means here how many bags are there? Here we have only 3 boxes are there. Box 1, box 2, box 3. So 3 boxes are there. So for that, so probability of A divides. So that is EI divides A equal to P of A divides EI into P of EI divided by summation I equal to 1 to how many boxes are there? 3 boxes. So probability of A divides EI into P of EI. So that means so substitute I equal to 1, 2, 3 here. So that means we will get. So here we are choosing only box 2. That's why we are writing here E2. Okay. So probability of E2 divides A equal to probability of A divides E2. Probability of A divides E2 into P of E2 divided by summation I equal to 1 to n probability of A divides EI into P of EI. So that means, so we have to substitute I equal to 1, 2, 3 here. So then we will get probability of A divides E1 into P of E1 plus probability of A divides E2 into P of E2 plus probability of A divides E3 into P of E3. So this is our main formula. So here we have to substitute all those values. So we have already, so probability of E1 is 1 by 3, probability of E2 is 1 by 3, probability of E3 is also 1 by 3 and probability of A divides E1 is 2 by 5, probability of A divides E2 is 4 by 5, probability of A divides E3 is 3 by 7. So substitute all these values here in this formula. So that means the probability of A divides E2, that is 1 by 3, probability of A divides E2 is 4 by 5, probability of A divides E2 is 4 by 5 and probability of E2 is 1 by 3. Probability of A divides E2 is 4 by 5 and probability of E2 is 1 by 3. Probability of E2 is 1 by 3 and P of A divides E1. So P of A divides E1 is 2 by 5. P of A divides E1 is 2 by 5 and P of E1 is 1 by 3. P of A divides E2 is 4 by 5 and P of E2 is 1 by 3. P of A divides E3 is 3 by 7 and P of E3 is 1 by 3. So all these values are here. So substitute all these values here. So after simplifying, we will get this solution. So here we have note about previous problem. So that means, so probability of E2 divides A means, very important note, probability of E2 divides A means getting white ball which coming from bag 2 or box 2. P of E2 divides A means getting a white ball which is coming from bag 2 or box 2. So like that, probability of A divides E2 means selecting bag 2 and then getting white ball. Selecting bag 2 and then getting white ball. So that is probability of A divides E2. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.